Good morning. I'm Robert Dick of the Royal Astronomical Society of Canada, or RASC. I'd like to introduce you to the Canadian Dark Sky Preserve Program and what would appear to be the only guidelines for outdoor lighting that can be used to preserve the night sky. The reduction in light pollution is more critical for the ecology of the night than for astronomy. Life is a balance, and light pollution strains a key component that maintains that balance. However, we're all human, and our perception, our values, and our approaches to the problem of light pollution have been molded by our culture and by our society. For example, we like activity at night. We like to read at night. But these are alien activities, genetically speaking. Our genetic predisposition is that of a hunter-gatherer, which is not much different from the animals we hunted in the past and study today. We suggest this is one of the problems we face in raising awareness of light pollution as an environmental disruptor. Although the RASC has been around for a long time, our light pollution abatement program was only formed in 1991 and has taken about 30 years to mature. Although we have a lot of members in the RASC, there is only a handful in our Light Pollution Abatement Committee. Astronomers like to observe, not lobby. Our program is unique with two general requirements: an administrative component that includes documentation for management and outreach, and a lighting protocol, the Canadian Guidelines for Outdoor Lighting, prosaically called the CGOL or Seagull. We'll summarize this guideline later in this talk. The RASC Dark Sky Preserve program has had 2 decades of growth and lessons learned. Our current designated area is about 63,000 square kilometers. As of September 2019, there were 22 dark sky preserves, 2 nocturnal preserves, and 2 urban star parks. There are currently another 4 preserves in the pipe. However, some of our lessons learned indicate problems on the horizon that may be of concern for other dark sky programs. Although the DSP application requires a commitment to reduce existing light pollution and comply with the lighting guidelines, problems persist after several years. Light pollution images and later confirmation using Google Road View shows outdoor lighting from built facilities continues to contaminate large areas of some of our dark sky preserves. Park administrators understand the administrative requirements, but the lighting has proved to be a persistent problem. We think there are 3 reasons for this. First, most of the park managers were raised and educated in cities where outdoor lighting is ubiquitous and goes unquestioned. Virtually every consumer, commercial, and industrial light fixture has been designed and marketed for their high impact on the night environment. Second, park managers may have started their careers as biologists and ecologists, but none of them learned about outdoor lighting and its impact on animals. This is a relatively new concern, arguably less than 20 years old. So when the impacts are explained in terms of ecology, they quickly understand its importance, but they're still unprepared to make the decisions required to reduce these impacts by changing their infrastructure's best practice. And third, most facility managers and electricians who select and install the lights only have experience with urban-style lighting. The suppliers in their speed dial or their Rolodex have never heard of low-impact lighting and generally don't understand why anyone would want it. They have the age-old opinion that light should change the night, so they guide their clients towards those solutions, rationalizing these with safety and security. In other words, homocentric paranoia trumps ecology. These biases make low-impact lighting seem like an oxymoron. Relaxing the lighting requirements to make it easier for parks to get a dark sky designation is one way to go. The IDA has found that this has merit. However, the RASC has decided their program will be guided strictly by the science of scotobiology, which is the study of the biological need for periods of darkness, not urban best practice. The RASC focuses their program on the ecology of the night. We consider the clear, dark, star-filled sky as only a symbol, the eye candy for the environment. The The anonymous creatures of the night are the real raison d'etre for dark sky preserves, hence our stubborn adherence to these guidelines. The RASC developed the Seagull to protect the night environment. It sets limits on the 4 critical attributes of lighting such that the combined effects provide sufficient light for human activity while minimizing its impact on the ecology. These guidelines are freely available from the RASC Light Pollution website. This 47-page document also explains the rationale for the guidelines, provides alternatives to lighting, and specifies the acceptable lighting attributes for a range of applications. It also provides background information to help in the selection of compliant luminaires. The rationale behind the Seagull has been published in the Lighting Research and Technology Journal. The Seagull took 5 years to develop, yet it has proved to be robust, continuing to be supported by new research in the field. When the guidelines were completed over 10 years ago, we found the illumination levels were not that different from basic commercial guidelines. However, the IESNA roadway lighting recommendations offer only illumination and luminance limits. They don't specify the ecologically critical color, shielding, or timing, or scheduling. The Seagull begins with darkness, but to permit human activity, the various light attributes are increased and balanced until there's sufficient visibility for humans and stops there. The key to these limits is in the broader and balanced approach that includes the 4 critical attributes of light. Since the Seagull was primarily developed for dark sky preserves, it didn't really matter that it didn't conform to urban best practice. An obvious question is, why would we allow any artificial light? The answer is that humans use that light for their outdoor activity. Not satisfying this basic requirement undermines whatever artificial light was being proposed. Our Seagull was developed in 2008 for Parks Canada. In 2012, the International Dark Sky Association recognized them along with other groups. However, the IDA later removed them as a requirement for their programs, favoring a more popular approach. One lighting solution will not suit all applications and uses for light. For example, a light may illuminate the ground or mark destinations and hazards. The first is an application of illuminance and is usually called on to increase the safety of visitors. The second is luminance and is used to attract attention for navigation or as a guide to a destination. These are different and potentially conflicting solutions. Limits on the fixture luminance should recognize that our eyes will be dark adapted in a dark sky site. If your goal is to get pedestrians' attention, you need not go brighter than the brilliant Venus, which is about 1 candela per square meter. To put this into perspective, the full moon, the brightest natural nocturnal light, is about 4,000, and a half moon is a bit less than 1,000. In contrast, the small light source in a luminaire has to light up a road surface that is 200,000 times the area of the lamp. For a road surface to be half a candela per square meter, the lamp needs to be correspondingly brighter, or roughly 100,000 candela per square meter. And then multiplying this by the albedo of the surface, we get over 1,000,000 candela per square meter. Therefore, street light is much too bright to be used as a marker in a rural setting. The least expensive way to comply with the Seagull is to leave the area natural. But assuming this has already been considered and dismissed, the next option is to use passive techniques. The RASC and Canadian parks are compiling these passive techniques that work quite well for pedestrian traffic and even for vehicle traffic. All of these are based on common sense. One is to use crushed white stone covering the ground. Asphalt should not be used because crushed stone is 10 times the albedo of asphalt. So for a given luminance, it requires considerably less illuminance or incident light. It's visible under starlight and appears to glow under moonlight. A second technique is using retroreflective materials, for example wristbands and painted bollards or steps or railings. The person approaching with their flashlight will see a prominent glowing object in high contrast against a dark background. This gets their attention so they can prepare to act, either avoid or approach. A third technique is to use phosphorescent materials that re-emit the energy absorbed in daylight. Although passive, These small discs mark a path, obstacle, or building throughout the night, even when overcast. An overcast night can be absolutely black in some rural areas. You can't see anything. However, phosphorescent materials glow continually throughout the night, even when no one is present. A fourth technique is rather obvious. Areas that are closed to the public at night should be left dark. Illumination or marking will attract attention and raise curiosity. Anonymity is the best security. Only when passive techniques are not sufficient should managers move on to active lighting with light fixtures. There are two ways to make outdoor lighting compliant: modification and replacement. Modifying existing luminaires can be done with little material cost. Changing the lamp to a different color or lower wattage may be all you need. But in some cases, adding a shield may be necessary as well, but may violate the warranty of the fixture. The main cost in these options is the labor or effort required in doing it. Remember that volunteer labor is precious and shouldn't be wasted or abused. Most consumer and commercial lights may need all four attributes to be modified. One of the main ecological disruptors of light is the blue spectral component, which makes the light look white. Even warm white contains too much blue light. There are two techniques. You can either use amber lamps or LEDs, or filter the emitted light. Amber fluorescent lamps and LEDs use a phosphor to convert the short wavelength blue light into longer wavelengths, making the light look amber. In Canada, these lamps are called bug lights. However, they tend to be available only in relatively high wattage bulbs and require shielding to keep the light within the target area. This conversion causes a loss of about 5 to 25% of the light energy. On the other hand, colored filters can cut 10 to 40% of the light energy, depending on the color temperature of the original lamps. However, filters may be easier to find than amber light bulbs. Filter materials are usually rather delicate and may need to be sandwiched between plastic or glass plates to make them more robust. However, filters are easily placed and protected inside light diffusers, and they're inexpensive. For example, the RASC-LPAC number 15 deep straw filter shown in this slide. In the lower right of this slide shows this filter film that effectively cuts the offending blue light. Under low illumination, our eyes desaturate and the color in the lower right leaves the impression of candlelight. The amber light has very little effect on the constriction of our iris, night vision, and animal circadian rhythm, with a melatonin suppression index of less than 5%. And it has low attraction for mosquitoes, the bane of Ontario summers. Also, its relatively low scattering in air increases visibility in haze or fog and produces less sky glow. So there are many practical benefits with amber light, as long as you don't mind candlelight. Shielding is arguably as important as color when we consider protecting the night. However, the type of shielding depends on the rationale for the light. Marking or illumination. If a marking light is wanted, then luminance is your goal, and light should not be shielded. Examples are navigation lights along a road or tower-mounted aviation beacons. In this figure, full cutoff shielding in the top diagram emits 10% of its light in the glare zone just below the horizon, whereas below it, the sharp cutoff shields allow only 1%, significantly reducing the glare and the resulting light trespass. Most full cutoff fixtures allow significant backlight, but this can be minimized with proper optics and shielding. The light loss at a distance with sharp cutoff shields can be dismissed because it doesn't contribute to the illumination of the target area, it just causes glare. Brightness can refer to illumination level on the ground or luminance of the navigational light. The goal of illumination is to make the surface or ground visible. How much light is used depends on the albedo of the surface and the amount of light needed for the activity. For example, walking needs about 1 lux or reading between 2 and 3 lux. Reducing glare and blue light components helps preserve our night vision and prevents the constriction of our pupils, so less light is needed, which compounds the savings. This may not be practical for urban areas due to collateral lighting, but this is less of a problem in parks and nature reserves. There's a curious difference between what we measure and what we see. Yellow light has 1/10 the impact of glare as blue light. I believe this is due to our brain sensitivity to the blue light channel from our retina. Therefore, although a photopic light reading of blue light will give a reasonable value, it will appear to be 10 times brighter than a similar reading of yellow light. Determining the appropriate schedule for outdoor lighting was particularly interesting when we developed the Seagull. There's 3 key drivers. Most vehicle traffic, and by proxy pedestrian traffic, is down to about 1/4 peak levels by 2200 hours. So low impact light fixtures should be dimmed after 10 p.m. or turned off. Also, most of the Earth's temperate zones have peak pedestrian and vehicle traffic in daylight for more than half the year. So for most of the time, the lights can be set to 1/2 their rush hour level. Using traffic as a proxy for pedestrian traffic and anecdotal reports from public campgrounds suggest their luminaires can also be dimmed or turned off at about 10 p.m. There's also an ecological argument for this dim time. Animals and plants time their behavior in part on the length of the darkness of night. But they have a behavioral plasticity or flexibility to accommodate the effects of cloud cover and the event of an early or late snowfall. Taking these into account also support a dim time of about 10 p.m. Such scheduling is now very easy to do using automatic controls and appropriate algorithms. The schedule in the lower right of this slide is used in the CSBG Ecolite. Replacing lights with compliant luminaires is more costly than modifying existing ones, but require much less work and will more likely be effective. However, the selection of luminaires requires a careful assessment of the various product options. The product data sheets must be critically studied to ensure the proper spectrum, shielding, brightness, and controllers are available. The Seagull has appendices that help convert the dark sky requirements into more typical information provided in the luminaire data sheets. We think all this is good information to have when developing a dark sky program, but I suspect we've been preaching to the choir, so to speak. However, our next necessary steps will be to take us out of our comfort zone, because it requires us to take on the task of making change happen. Most managers would like to do the right thing, but they don't know what that is, or how to turn aspirational words into a hardware specification. This means meeting decision makers and repeatedly suggesting, asking, even demanding that low-impact guidelines be included as a lighting specification in their request for proposals, or RFPs. The supplier can only provide what has been asked for in their contract. A luminaire that complies with the Canadian guidelines for outdoor lighting is called the low-impact luminaire. It must control and balance color or the spectrum, the glare with shielding and optics, brightness and timing or the scheduling of the light. An example is the CSBG Ecolite. The most obvious attribute is the color. It emits no blue light, which results in the amber color. The next characteristic is the shielding. This luminaire has a sharp cutoff design that limits the glare to only the illuminated area, which is already contaminated. But the light will not shine out of the target area into the bush or forest. The brightness is lower than most fixtures for about the same visibility because it emits no blue light or glare, thus protecting our night vision. Its optics also distribute the light to avoid small bright patches at nadir. All of these allow a lower brightness, which reduces the energy consumption to less than 1/5 of most urban lights, which also makes them attractive for off-grid applications. It was designed for parks that have many different needs for lighting, from 1 meter high for a pathway to 6 meters for a road. So its controller allows the user to customize the performance of their specific application to prevent overlighting. And it automatically dims the light after hours, so park staff don't have to stay around to turn it off. The bottom line is that low impact lighting lets you have your cake and eat it too. Indeed, it's not something that should be developed, it already exists. In summary, the stakes are high, but what is good for the ecology is also good for most astronomy. An ecological rationale has been used to develop a practical lighting guideline that will help preserve the ecological integrity of the night and protect the night sky. Of course, the lowest impact is with no artificial light, so before a manager selects an outdoor light, they should be very sure it's needed and no other solutions are practical. When artificial light is deemed necessary, then the seagull should be used to guide the luminaire selection. The Ecolite proves all this is practical and at a competitive cost. Thank you. I hope you find some of this helpful.